What does layer.get_weights return? I'm using Keras to do some experiments and I just monitored the weight update for a simple MLP model. For the first dense layer, I got a matrix of zeros. I thought the training doesn't change this weight. However, weights in other layers are changed. So I'm confused why the first layer is unchanged. I checked the source code but still got no answer, then I tried monitoring. This time, the weights did change. So I'm wondering which weight is the true weight that is working during training? Why there are two elements in the weight list? Definition of MLP.
For the question of layer.get_weights, I ran some tests on this issue and checked the source codes. I found that the dense layer is a subclass of layer and its weights, which is a type of Python list, has two elements: weight of the layer stored at layer.get_weight0, and the bias is stored at layer.get_weights1. There's one thing to note, that bias can be disabled during defining the layer. Model.addDense 503, init equals normal, activation equals relu, bias equals false. In that case, the list, layer.get_weights, has only one element. If you set the bias attribute as false after defining it, there will still be an element for bias and it would be updated after you fitting the model. For the question of not updating, I set up a sequential model with only one dense layer. Def MLP_2 column model equals sequential model.addDense 10, input_dim equals 784, activation equals softmax, bias equals false, return model. Then I use the same way above to compile and fit it. This is what I got. It still seems not update the weight. However, we can tell the weight is definitely changed, because the accuracy is increasing. I think the only explanation is updates on the first dense layer, which you define input_dim, is too small for Keras to print out. I didn't check the more precise value of the weights. It would be great if someone could confirm it.
Here is a working example.
There is a way to see exactly how the values of all weights and biases are changing over time. You can use the Keras callback method, which can be used to record the weights values at each training epoch. Using a model like this, for example, add the callbacks called during fitting, where the callback is defined by This callback builds a dictionary with all the layer weights and biases, labeled by the layer numbers, so you can see how they are changing over time as your model is being trained. You'll notice that the shape of each weight and bias array depends on the shape of the model layer. One weights array and one bias array are saved for each layer in your model. The third axis, depth, shows their evolution over time. Here we use 10 epochs in a model with layers of 16, 12, 6, and 1 neurons.
I feel vant to se enore, per accettare gigares of streaming.